The term natural philosophy used to denote all of the sciences. By used to, I meant not too long ago, maybe 50 years ago, it was still called natural philosophy. Newton would have been considered a natural philosopher. Physics kept the name natural philosophy longer than most, though, because it's spanning of all the sciences. The physics principles make up the underlying basis of all the sciences. And we'll take a look at physics' relation with other fields of science. So first, let's take a look at chemistry. Chemistry and physics have long gone hand in hand. Advances in chemistry directly affect physics, and advances in physics directly affect chemistry. The periodic table of atoms, of elements, were a way of chemists to group together things with common properties. Out of this, physicists created the theory of the atom, right, which later physics found to be controlled by quantum mechanics. Which is now what we use now in chemistry to figure out new molecules and create new molecules or new drugs or stuff like that. Statistical mechanics and or thermodynamics are also based in physics but are used in chemistry because these are what control chemical reactions and reaction rates, that sort of thing. Our next science we'll look at is biology. Obviously there are a lot of things in biology that relate to chemistry, but also a lot that relate directly to physics. Conservation of energy, which we'll get to later in our class. Calories, if you take in so much energy, you burn so much energy, you have to take in so much energy. Circulation of the blood, different types of pumps, pressure, blood pressure, that sort of thing. Electrical conductivity, all your nerves and muscles use some sort of electrical conductivity to create their action. And part of that is the chemical potential along membranes that create whether or not a certain substance can go into the cell or not. How enzymes and proteins work. Protein folding is something that's coming out of physics and biology, where the improper protein folding causes some disease, so they're looking at how that happens. Experimental techniques that have their basis in physics are also used a lot in biology and in chemistry. Some of those are isotopes, tracking isotopes, X-ray. The original structure of the DNA was the double helix was figured out using X-ray diffraction. Magnetic resonance imagery, or MRI, and also CAT scans use a nuclear magnetic resonance. It also has other sciences. Obviously, astronomy is a closely related one. Geology, and probably a lot of you students are in engineering. So I had my previous class have them come up with ideas for how physics relates to engineering. They came up with statics. Obviously, a lot of your engineering will be statics, and we'll cover a chapter in our class about statics, and it's one of the first introductory classes you will take in engineering. Torque we'll also cover in this semester. Loads, different types of materials are also based in physics, and of course thermodynamics.